Good morning everyone. Once again welcome back to my channel Stream Mechanical. So today I am going to solve a problem which is based on the machine and machine tools chapter, and this is about me. Okay, so let's go to the problem directly. So here you can see a question is written that while turning a metal rod of diameter 100 mm, so diameter of the job is given at a speed of 625 rpm. The feed is also given 0.4 millimeter per revolution, and the depth of cut is 5 mm. And the tool used is the carbide tool, and the geometry of the tool also provided 0 degree, minus 12 degree, 6 degree, 6 degree, 30 degree, 60 degree, and 0 mm. This is the radius in terms of mm. You have to remember this point. Then other following observations are given, like tangential force 1200 Newton, axial force 400 Newton, and the chip thickness is given 1 mm. Now what we have to remember, actually determine, now we have to determine the values of different forces: the friction force, normal to friction force, shear force, and the normal to shear force. So this question is looking very simple, but there are lot of points I want to discuss. You just stay with this video. At the end of this video you will get a lot of point. Okay, so first let me write that what are the points actually on the given data are present in that question. First, the feed S0 is given for 0.4 millimeter per revolution. Depth of cut is also given, chip thickness also given, and the tangential force and axial force is given, and the tool geometry is given. Now first let's write this tool geometry, and what you can, first of all, what you can understand from this tool geometry. First point you have to be note, tool geometry given in nose radius R is provided in mm, correct? So means it is either ORS system or NRS system. We don't have any idea what is actually, it is ORS or NRS, but out of these two it is not a ASA system. Okay, so here actually nothing is provided about this ORS or NRS, so we will go with this ORS. Okay, means, so according to the ORS system, this first angle is actually our inclination angle, lambda is equal to 0 degree. Second angle is our orthogonal rake angle, that is minus 12 degree. Now these two actually not required, these two also required. This is the phi 1, this is the auxiliary cutting edge, this is 30 degree, and the principal cutting edge phi is equal to given 60 degree. So these are the first point we have to be understand from the question. Second one is the tangential force Pz is equal to 1200 Newton, correct? And the Px is equal to 400 Newton. Now first point, what actually students think, that let me discuss this point with help of the merchant circle diagram. Here you can see this is our Pxy and this is our Pz. Actually this is the tool. So here this is the PS shear force, this is the normal to shear force, this is the friction force and normal to friction force. Okay, and this is my tangential cutting component force or main cutting component force, you can say, and this is the normal to that main cutting component, this is the Pxy. Now most of the students think that this Pz is okay, whatever the Pz is given 1200 Newton, this one is okay, this is the value. But what about this Px? Okay, most of the time students think that this Pxy actually 400 Newton. Okay, but this is wrong. Pxy is not 400 Newton. Here Px is 400 Newton. Means if I draw a simple turning operations, let's say like this. Okay, let's say this is our machine surface and this is the my workpiece job, the remaining portion, and this is my cutting tool, correct, like this. Then here this is the Py component of the force, this is the Px component of the force, and this is the Pxy component, means the resultant of this Px and Py, and this angle is phi. Okay, this angle is phi because here this is the principal cutting edge angle phi. So if this is the phi, these two actually perpendicular to each other, py and this feed direction, so this is 90, so this angle is 90 minus phi. And again, so this angle pxy and this edge of the cutting tools are 90 degree to each other, so this angle actually phi. So what actually we can write, we can write that this px is equal to your px sine phi and this py actually your pxy cos phi. Correct or not? If these two things are correct, then how you can say this pxy is given? Actually given data is your px. So first you have to find the value of pxy from this given data. Px 400 by sine of phi is, already I told that phi is 60 degree. Okay, so 60 degree. So if you solve this question, you will be get the value of pxy around 461.88 Newton. So this is your first point you have to observe, and you have to find out the values of the force. Otherwise, if you start solve the problem with by taking this two, okay, means this pxy as a 400 Newton, then your whole approach will be wrong. Okay, so we have pz 12 Newton and pxy we have 461.88 Newton. I hope up to this one is clear. Now we have to find out the forces. Now we have two things actually, means the two way I can approach or we can go to find out the forces. One is this merchant circle diagram. Okay, means we can write whatever the pz and pxy we have now. So I can write this pz is equal to my this r into cos of eta minus gamma naught. Okay, because you know this is the pz and this is the pxy. Okay, so this angle between this pz and pxy is my eta minus gamma naught, where eta is the friction angle and gamma naught is the orthogonal rake angle. You can see this is the orthogonal rake angle. Okay, this is my reference plane actually, and this is my rake surface. So this angle is my orthogonal rake angle, because this view is on the orthogonal plane. Okay, whatever the view we are drawn here is on the orthogonal plane. Now when we have the r, we can find out any of this force, because you can see this f also related to r, because you can see this one for f and n also resultant is same, for ps and pn also the resultant is same. So when we have the value of resultant, we can find out any of the forces. Okay, so let's say we have the r value pz by cos of eta minus gamma naught, and similarly we will be get the values of f, n, shear force ps, normal to shear force pn. Okay, this is the one. Another is that you can directly remember the formula. How you can directly remember the formula? Let me erase this thing here. Okay, directly we have few formula to find out the forces in terms of the tangential force and this resultant force pxy. These forces, these equations are like friction force F. Okay, this friction force F is equal to now you know this friction force in terms of this thing. So this is pxy cos of gamma naught. I will be explain that how actually I can remember this equation. You can remember this equation. So wait for a second. This is sine gamma naught, then normal is your pz. Okay, normal is pz cos of gamma naught minus pxy sine of gamma naught. Then we have shear force ps. This ps is pz cos of gamma naught minus pxy, sorry, this one will be the beta naught sine of beta naught, and the pn is equal to your pxy. This pn is equal to your pxy cos of beta naught plus pz sine of beta naught. Now let let me say in a very short way that how actually I remember this one. When you are writing F na, so you have to remember from this merchant circle diagram, you have to say what is the opposite force of this F, means actually geometrically. Okay, so in the opposite of F there is a present of Pxy, correct? So I'm taking Pxy, and with the opposite force you have to write the cos component. So Pxy cos gamma naught, then remaining is the plus Pz, because already Pxy taken, so Pz into sine gamma naught. For n also the same thing, n is here, the opposite of n is Pz, so Pz, and what I said that with the opposite component cos component, so Pz into cos gamma naught, then Pxy into sine gamma naught. Now why I write here gamma naught? Because when you talk about the friction force, you know what the angle actually comes into picture, the angle gamma naught, the effective, sorry, the orthogonal rectangle gamma naught will comes into picture. That's why here with the cos and gamma, cos and sine, gamma naughts are written here. Similarly for the PS and PN also, here PS, opposite of PS is PZ, so PZ cos, and you know with the shear force, shear angle is related, so that's why here instead of gamma naught I written here beta naught, because here beta naught is your shear angle. Okay, and gamma naught is your orthogonal rectangle. Okay, so similarly Pn, how you can write the Pn? Pn is your opposite force is Pxy, so Pxy, and with the opposite one cos component, so Pxy cos beta naught plus Pz of sine beta naught. Okay, and how you can remember this negative sign? Because you know when you are talking about the friction force and normal to friction force, what actually we think first, we have to first think about the friction force. Okay, so with the first component we have plus, so opposite one we have minus, and the opposite we have to do when we are talking about the shear force and the normal to shear force. Shear force will comes into picture first, so this component have negative. So actually you can repeat the video and you can remember that how actually I remember these forces, because listen, this diagram you have to remember very easily, and then from the diagram you can write this equation. So no need to remember how actually I have written, just remember the point or the away you can remember, so that after seeing this diagram only you can write this equation. So let's back to the solving this question, that we have two things, either we can go like this, we have the r value first, then we can write here what I can write, that r is, sir, f is equal to this r into sine of gamma, sorry, eta. Okay, then n is equal to r of cos of eta, then ps is equal to r of your cos of eta minus gamma naught plus beta naught. Similarly Pn I can write r into sine of eta minus gamma naught plus beta naught. So either you can go with this direct equation or you can find the r value, then you can go like this. Okay, these two approach you have. Let's say if we want to go with the direct equation, then we will be get that we have, let's say ps. Okay, so ps we have pz, ps we have pz into cos of beta naught minus pxy sine of beta naught. Let's put the value. We have pz is equal to 1200 and cos of beta naught. Now question is that we don't know the beta naught. Maybe if we are discuss about this equation, okay, or this equation, in this if we follow these equations, then the beta naught is unknown for me, correct? If I follow this equation, then this friction angle eta is unknown for me, correct or not? Now either if you want to solve by this question, these equations, then you have to find out eta, or if you want to solve by this equation, then you have to find out beta naught. So let me first find out the beta naught. Okay, how I can find out the beta naught? That we know that tan of shear angle beta naught is equal to cos of gamma naught by zeta minus sine of gamma naught, correct? So here also I know the gamma naught value, but zeta is unknown. Let's first find out the zeta first. Zeta is your chip thickness by the uncut chip thickness. Chip thickness is given, you can see 1 millimeter, but uncut chip thickness not given. How we can find? There is a equation, this S naught into sine phi, feed into sine of the principal cutting edge. So if we know the S naught value, this is 0.4, and we know the phi value, this is 60 degree. You can see principal cutting edge angle 60 degree. So if you put this value, you will be get the value of zeta around 2.887. So if you put in this equation the value of zeta 2.887 and gamma naught value minus 12 degree, okay, so from here you will be able to find out the beta naught value. How much beta naught value? You will get the beta naught value around 17.54. okay, 17.54 in degree. So when you have the beta naught value, you can put it here, 17.54 degree minus, we have the pxy around, how much pxy? 461.88 Newton, correct? Already we are find this one. So 461.88 into sine of 17 point, let me erase this portion, 17.54, and you will be get the values of, if you solve this question, then you will be get the value of around 1005 Newton. Okay, now similarly if you find the value of Pn, there will be, now Pn is opposite is the pxy, so pxy cos of beta naught plus pz sine of beta naught. Actually just you have to practice these equations 2-3 times, and the way you can remember, you have to understand that concept, then only you can write this equation without any hesitation. Okay, now if you again, if you put the value like 461.88 into cos of this one 17.54 plus your 1200 into sine of 17.54, then here also you will get the value around 802. okay, 802 Newton. Please check these values. Actually I calculated and got these values, but I request you, please you also solve by your own and check that the values are correct or not. Now write the values of f value. You can write like pxy cos of here gamma naught plus pz sine of gamma naught, and if you put the values 461.88 into cos of here minus 12 degree plus pz is 1200 into sine of minus 12 degree, and if you find this value, you will be get around 202.3 Newton. Okay, now we have the normal to friction force, the last one that we have. Normal to friction force is that pz cos of gamma naught, because this is the normal to friction force, and what is the opposite to it? Now opposite to it is the pz. okay, this pz, so pz into cos gamma naught minus pxy into sine of gamma naught. Let once again put the values, 1200 into cos of gamma naught is minus 12 degree and minus pxy is 461.88 sine of minus 12 degree. okay, and if you solve this one, then you will be get the values around 1269.8 Newton. okay, so these are the actually the questions you have to solve, and these are the actually the values what you want: ps, pn, f and n. Now what the point actually you have to remember, once again I am discussing that point, please remember this. Actually listen, if you remember those points, then solution is not a big deal, but those points you have to remember. And I'm going to discuss that what are the other possibilities is there that this question can be formed in the other way also. Okay, Okay, let's me write. So here the first point is that this thing, okay, this thing you have to remember that what are the forces are given. Actually most of the time pz is as it is, you can see from the figure also, pz is as it is, there is no problem. But this component is not your this component, okay, this component actually not your px or py component. This is the resultant of px and py. Okay, so if in the questions px or py is given, don't think that this value is given. Okay, and we know the relations from this diagram, that if this is our px y and this angle is phi, so py is nothing but your the px y into cos phi component, and px is equal to your sin phi component. Okay, so this thing you have to remember, first point. Second point, now then few times actually this value, whatever the value px is given now, this is equal to your pxy only. As a result, what happens, students don't know actually that what they are doing, then also they are getting the right answer. Okay, you are got my point now. Student actually doing the mistakes only, they are taking this px as a pxy, then also they are getting the right answer. What is the reason is that this angle, okay, if instead of this 60 degree, if this angle is given as a 90 degree, then what will be happened? Okay, this one is our py, this one is our pxy, and this one is our px, and the angle between this is nothing but our phi. Now right now it is 60 degree, correct? Now if I change this 60 degree to 90 degree, then what will be happened? This py will be as it is, this px will be as it is, but this pxy, which is initially here, okay, which will be changed to the here, correct or not? Because this time the angle between this is 90 degree, correct? So this is the reason, if our principal cutting edge is 90 degree, that time this pxy is equal to px. Okay, so if in question this is given principal cutting edge is the 90 degree, then you no need to find out the values of py and px like this way. Directly you can take the px value as a pxy. This is the first thing. Second thing is that when we actually in the next slide here, when we discuss about the CR angle beta naught, here this point, when we are discuss about the CR angle beta naught, that time what actually we did, that wait for a second, let me erase this thing. That time we are following this equation, correct? Tan of beta naught is equal to cos of gamma naught is equal to your zeta minus sine of gamma naught. But we have other options also to find out this beta naught. What are those options? First option is that we know there is an equation 2 beta naught plus eta minus gamma naught is equal to 90 degree. We have another equations beta naught plus gamma, plus eta minus gamma naught is equal to 45 degree. Then why we are not use this equation or this equation? Why only this equation? This is the first question. Second question, if I followed this equation, then can I get the same value of beta naught? The answer, this is the second question, and the answer of the second question is that no, there is no, there I will be get a different solution. What is the reason is that there is such conditions are present, at that conditions only I can use this equation or this equation or this equation. Condition is that first one for this equation. What is the condition for this equation? The condition for this equation is, if in the question they are given, solve the questions by following Merchant's theory. Or minimum energy principle, minimum energy principle. If these two things are mentioned, any one of these, there is no mandatory, both are mentioned, actually either Merchant's theory or minimum energy principle, then you can follow this equation. This time you can't follow this equation. Are you getting my point? This time you can't follow this equation. This time you have to use this equation. Now when we can use this equation, when you can use this equation, we can use this equation when there will be mentioned that solve the equation by following Lee and Schaeffer's theory or slip line theory. Okay, actually this Lee and Schaeffer established this equation by following this slip line theory only. So that's why any one of this sentence or word can be present there. So that time you can use this beta naught plus eta minus gamma naught is equal to 45 degree. Or if it is mentioned that the followed by the Merchant's theory, we have to solve the question, or by according to the minimum energy, theory, then you can follow it this equation, that 2 beta naught plus eta minus gamma naught is equal to 90 degree. Correct? So these two. If nothing is mentioned, either this one or this one, then you have to go with this tan beta is equal to cos gamma naught by zeta minus sin gamma naught. I hope these 2 points what I actually want to discuss through these questions are clear. Okay, first concept is that related to this force. Second question is related to point is related to this beta naught. Okay, so I hope the points are clear. So in this video this much only. In the next upcoming videos I will be discuss another topic, okay, which will be helpful for your any kind of competitive exam. Thank you.